Okay, so the question is that you're a lead data scientist. We will keep a rough work scratchpad just for rough points here. Okay. Now, what does it say? You're a lead data scientist at Amazon Music. Your task is to build a music recommendation system that takes into account user preferences, user interests, and provides new songs that gets added to a daily list of music recommendations. Daily one list of recommendation per user. Let's say we have about, I don't know, 1 billion. 1 million might be too much, so 100 million daily active users for which you have to generate this. Considering the latency, it's fine because once a day. So it would be fine if there's a complex network. Basically it would be fine if some complex DNN is there. High accuracy in terms of songs recommended and clicked on. High accuracy, okay. So user preferences, we'll have genres that they like, maybe language that they listen to in the music, and is there anything else that you provide? Maybe artists that you follow would be there. Interests would be more derived from music played. Got it. And now has a training time limit of 2 hours for all the users. I don't know how we'll incorporate this last part. Seems a little weird, to be honest. Training time limit of 2 hours. What does that mean? I have no clue. Alright, now if we think about few things, like say, let's think about metrics, right? Now online metrics, yeah. From an online perspective, what you'd want is on a daily level per session, how many of those get clicked or played, right? But you would not want songs which have been played only say for 5 seconds, 10 seconds, or that got skipped, because those are not the songs. If you're recommending something, probably people would click on it. There's no other way to judge a song other than just playing it for a few seconds. So from that angle, I think it'll depend upon how many successful plays happened in that recommended list, which the user listened to almost completely, right? So successful plays per session. And it's possible that a user listens to something on repeat, which again represents that's a good thing only for us, right? Uh, so another thing would be total play time in the day. That would be one. All right. Then what else? Um, from an offline metrics perspective, now we can't judge for any given user what should be the ideal, ranking, which means that something like NDCG would not work, which requires a set of people to label what would be the correct rankings, which then leads us to basically extracting historical data and checking that okay, if we had user data available till day t minus 1, then on tth day uh, what's our precision and recall and F1 score in the top K items, right? So perhaps that would make more sense here. Uh, F1 at K. Now, what would matter more to us here? Precision would mean that everything that you're recommending, almost all of them are good. Recall would mean you've recommended everything that could be good, uh, but there are a lot of bad things also in there. F1 score would be balance of both, right? Here we are more, uh, I think, concerned with precision. It's okay if our recall suffers. It's okay if you're not able to get all the kinds of songs for a particular person. Uh, with that said, there is this aspect of incorporating new artists. I think, which in some sense, if we go for F1 or recall, I think that itself might get somewhat accomplished. So that's why probably F1 at K would also make equal amount of sense to try out. Um, what else? Now, but one more way of doing this, incorporating new artists, would be just diversity. Uh, and we could implement diversity by, say, not recommending or penalizing the score of recommending songs from same artist, right? So we'll come up with some sort of a scoring mechanism, of course. Based on that, I'm saying that we can do this to just increase the diversity, which would then probably lead to recommending new artists. There could be other heuristical ways also, probably recommending. It can be more of a mix of artists which haven't had a lot of listening. But anyway, so this is about the metrics part. Now the idea is we have to recommend a list of songs, right? Which would basically mean that we want what do we want here? I would want that what is the probability that a song would get played given users preferences and the previous history of songs that user has listened to and liked. Oh, we'll of course have uh, maybe songs they've liked, song, yeah, songs they've liked could be it. Songs they've played on repeat could be another things, right? Those could be some important things. You would want to keep diversity also from the angle of genres, right? Uh, yep. Okay. given that it's a daily list. All right. What else is there? So we would have. So what we are doing is problem. We are just describing it as predict the probability of play of a song for the user, given user features, essentially context features, etc., and rank the songs accordingly, right? That is one way of doing things. Now all right, now what else do we want? We've got problem and metrics covered. You could think about how we're generating the training data, right? Before we move on to modeling. So training data. Now for training data, what I basically do is we have to think about ultimately we want what's the probability that a song will get played and the song is liked, right? Those are the two things. And are there some negative actions as well? Yeah, there are negative actions as well. So it might make sense to actually predict probability of play, like, and negative actions on a song, and make a relevance value function and rank it according to that. Got it. Now training data. For training data, you need points of songs that they've liked, they've not liked, they've played, but there were still negative points. Okay, how do you do this? If you have data up till the init day, you can see what they've played and for how long, right? And every song played but not completely listened is a negative point. Basically, skipped. Every song played completely multiple times, positive point. And every song liked is a positive point. Yeah, I should have asked what are the user actions available. Perhaps we have more than liked. Anyway, so based on this, we can generate data points, right? Yep. Would this yield more, an imbalanced data though? So if you think about this, will there be more positive points or more negative points? Well, it's possible that it is gonna yield imbalance, can cause imbalances for some users, right? This completely depends upon users actually. For some users, they'll be probably liking a lot more songs and not liking just as many. And some people have very specific tastes, some people have very varied tastes, right? So depending upon our algorithm and the way music is presented in the app, it's possible that some users are going to like a lot of the songs, some users are going to like very few of the songs. So in which case for some users they'll be in balance, for some users they won't be in balance, which means that we need to balance this out. Now how do we balance this out? You do need negative things, and can do undersampling or oversampling, right? Those are the only ways I can think about. Let me write down questions that would be asked. Questions to prepare upon. Precision at K, explanation. Imbalance at user level. How do you solve? Or undersampling, oversampling techniques I'm aware of. Okay, training data generation would be done like this. Take till 10th June, predict for 11th June. That becomes our validation data, and then there's test data. So something like that. Okay, then let's think about features, right? So what are the actors in play? User, song, context, right? So we'll have features across these. So let's talk about user features first. We'll have user ID, which is pass feature. We would have things like user genres, which is the interest that they've specified. Language is artists they follow. Something that will be quite important is how diverse is their listening, right? So that algorithm can fit to accordingly. Like if a user listens to a lot of varied songs in the same day, then that means that we can have more variety in our recommendations as well, right? So genres, listen to in last session, maybe num of genres, num genres listened to in last 7 days, uh, and that would be good enough. Similarly, we could do number of artists perhaps. Right, so that's an important part of the song. Song features will have like length of the song, genres. Would the cover matter? I think cover should not matter. Lyrics should matter. Lyrics is a big part. Lyrics, which has to be like embedding of the lyrics, we'll try to come up with a way, right? Genres is there. What else is there? Artist, right? Who sung the song? Who was featuring artist? What else? Popularity would matter, right? Number of plays in last 24 hours. Release date, something very recent would probably get played a lot more. Number plays in last hour. Last hour would be a bit difficult to calculate, perhaps. Uh, yeah, that would be a little difficult to calculate. What else? Maybe plays to likes ratio. That could be important. Yeah. Then context, right? Which is day of week. Uh, Perhaps is holiday or things like yeah, those are all the features I can think of. Now if we have to talk about modeling finally. How would our modeling go? We can have song ID. Now there are a bunch of things we can do, right? One is that we can generate embeddings for each song based on the play history, right? For example, like think of it like a word to vec sort of a situation, wherein based on the context of the songs you can get to know because which songs are kind of similar to each other essentially because when people are listening to songs they are usually in most people would be in a similar mood or a single mood, right? And they would want to listen to same sort of songs, right? Even if they are varying a lot across artists. uh, so this could give us song embeddings. And oh, there could be albums. I forgot all albums. uh, Album name, release date is something we covered, right? Yeah, covered. Now user song. Oh yeah, there'll be cross features, user cross song features. Number of plays. Okay. So what I was saying is, first I would basically create embeddings of songs based on users playing history, right? And once we have embedding, that becomes a feature in itself, right? So of users. Now we could similarly have user embeddings by just averaging out the songs that they've played and perhaps finding similar songs, but there's zero deep learning there happening. Yeah, we can do that, right? We could use the embeddings last day, 7 days, maybe last 30 days as well. Right, now once we get these embeddings, we can form all of these features, which can then go into, we can have song ID. For lyrics, we can use a pre-trained NLP model like BERT. Yeah, something like that would work. Sometimes people just like a lot more beautiful songs on low, or songs which belong to a particular topic or which are about a particular topic. So that's why probably lyrics can become more important. Okay, now we have all of these features, right, which get fed into a deep neural network model, and out comes probability. So feed all of this into all of these features into a deep neural network model, and out comes a probability of play, probability of like, probability of skip, and probability of not interested, right? And then you can assign diversity, could be in few ways. Again, one could be that you penalize having songs from same artists, penalize songs from same album, penalize songs which were recommended yesterday. Add scores to songs which have been repeated yesterday. Yeah, that is all I have basically. recommendation